Hello and welcome, of course, to your trigonometry class. I'm Mr. Marcus, your favorite summer school online math teacher, and today we're going to continue our discussion on trigonometric ratios. Now, in our previous video, we discussed the first three basic trigonometric ratios, which are sine, cosine, and tangent. Now, remember, these trigonometric ratios are present in 90-degree triangle, which is why it's also referred to as right-angle trigonometry. These trigonometric functions are found when we start talking about radians a little bit later on. So you are going to see the trigonometric ratios, but the six basic trigonometric ratios are mainly in right-angle trigonometry. So that being said, let's review them. We have our first three, which is sine, cosine, and tangent, and let's go over them right here in this triangle. Now the sine, we know, is opposite over hypotenuse. So here we have our triangle A, B, and C. A short leg, B long leg, C hypotenuse, and we're going to use the Greek letter Z or V or phi to be our angle of reference. So if I want to find the sine of Z or phi, I look at my opposite, which is the side that is farthest from the angle, over the hypotenuse, which in this case is A over C. If I want to find the cosine of Z, I look for the side that is closest to the angle, which in this case is B. So we say B over C. And if I want to look for the tangent of Z, that would be the farthest side from the angle over the closest, because it's opposite over adjacent. So that would be A over B. Now, there are three other trigonometric ratios that we're going to talk about, and they are the cosecant, the secant, and the cotangent. And basically what they are is the reciprocal of these. So for example, the reciprocal, or the opposite of the sine. If sine is opposite over hypotenuse, the reciprocal is to take it and flip it upside down. So the reciprocal of opposite over hypotenuse is hypotenuse over opposite, and that would be our cosecant. So if I wanted to find the cosecant of Z, that would be the opposite over the hypotenuse, because it's the opposite of the sine. So it would actually be C, which is my hypotenuse, over A, which is my opposite. Now if I wanted to find the secant, which is abbreviated SEC, it's the opposite of the adjacent, of the cosine. So if the cosine, So if the cosine is adjacent over hypotenuse, the secant is hypotenuse over adjacent, which means in this case the hypotenuse is C and the adjacent is B, so that would be C over B. And the cotangent, which is the opposite of the tangent. So if tangent is opposite over adjacent, the cotangent is adjacent over opposite. So for example, if our tangent is A over B, then our cotangent would be B over A. And those are the six basic trigonometric ratios. Now we're going to see an example in just a minute of finding all six basic trigonometric ratios. So I'm actually going to go ahead and erase this. And we're going to look at this example that I already started on this side. So let's say we have the triangle where the short side is 14, the long side is 48, but I do not have my hypotenuse, and I want to find all six basic trigonometric functions. Well, what we need to do first is find our hypotenuse, or the value of C. And I already started it. Just remember, we're going to say that the hypotenuse is A squared plus B squared equals C squared, right? So in this case, it would be A squared, which is 14 squared, plus B squared, which is 48 squared, is our C squared, or our C that we're going to be looking for. So what we do is we use a calculator, obviously, and 14 times 14 is 196, and 48 times 48 is 2,304. We're going to add that, and that's going to be 2,500. Now C squared equals 2,500, so what I'm actually going to do is find the square root of C and the square root of 2,500. So the square root of C squared is C, and the square root of 2,500 is 50, which means that 50 is our hypotenuse. And we're going to look for all six basic trigonometric functions. So we're going to look for the sine of Z, and we know that sine of Z is opposite over hypotenuse. So the opposite is the side farthest from Z, which is 14, over the hypotenuse, which is 50. So we say 14 over 50. The cosine of Z is adjacent over hypotenuse, adjacent being the side closest to Z, which is 48, over the hypotenuse, which is 50. Now, One thing that I want to let you guys know is that whenever we're working with ratios, we have to make sure that they're in their simplest form. So I'm actually going to first just write the ratios, and then we're going to see if I can reduce them. And the tangent of z, which is opposite over adjacent, opposite the farthest sine from z, which is 14, over the adjacent, which is the side closest to z, which is 48. So what I want to do now, before I look for my other three trigonometric functions, is just reduce. Can I reduce 14 and 50? Yes, if I divide by 2. And 14 divided by 2 is 7. And 50 divided by 2 is 25. So it's actually 7 over 25. I do the same thing here. 48 divided by 2 is 24. And 50 divided by 2 is 25. And for my tangent, it's the same. 14 divided by 2 is 7. And 48 divided by 2 is 24. So I have all of my first three basic trigonometric ratios reduced in their simplest form. So when you work with these exercises, you have to make sure that they are reduced in their simplest form. Now let's look for the others. The opposite of the sine is the cosecant. So if sine is opposite over hypotenuse, and I'm actually just going to go ahead and use the simplified versions of them. So the cosecant of z is the opposite of the sine. So if sine is opposite over hypotenuse, the cosecant is hypotenuse over opposite, so that would be 25 over 7. The opposite, or the secant of z, is the opposite of the cosine, and if the cosine is 24 over 25, then the secant, which is the opposite of the cosine, would be 25 over 24, excuse me. And the cotangent of z is the opposite of the tangent. So if the tangent is opposite over adjacent, which in this case is 7 over 24, then my cotangent is the opposite of that, which is 24 over 7. So again, ladies and gentlemen, all we did was find our three basic trigonometric functions, and then the other three are just the inverse of that. So if sine is opposite over hypotenuse, then the cosecant is hypotenuse over opposite. If cosine is adjacent over hypotenuse, then the cosecant is actually adjacent, or if the cosine is adjacent over hypotenuse, then the secant is the adjacent over the hypotenuse. If tangent is opposite over adjacent, then the cotangent is adjacent over opposite. So basically all you do is invert them. So along with this video, I am going to upload the exercises that you're going to use for practice. So we will see each other in our next class. Remember that this week's exam is based on all of the videos that I am uploading for your classes. So stay safe, and I'll see you soon. Bye-bye.